Hi everyone, today I want to quickly tell you about two things. One is our nodal tissue, right? The specialized cardiac musculature that we have got. And the second thing I want to tell you about is cardiac cycle. Okay, so nodal tissue, what happens is that towards the top right upper corner of the right atrium, like here, we have got something known as the sinoatrial node. Now, let me use a different color. This is our sinoatrial node. It's known as the pacemaker, right? So this is your SAN, sinoatrial node, or the pacemaker. Then towards the lower left corner of right atrium. Now I'll tell you I'll tell you a little about the sinoatrial node. So what happens is it can generate about 70 to 75 action potentials per minute, and this is its maximum range. It initiates and maintains the rhythmic contractile activity of the heart. So it is the initiator, it is the one thing that initiates the cardiac activity of the heart, because of which the heart is myogenic. It can initiate its own cardiac activity with the help of a pacemaker. Then we have an AVN, which is in the lower left corner of the right atrium. So AVN is somewhere over here, right? Now you may wonder what's the function of this AVN. So AVN actually is atrioventricular node. It is close to the atrioventricular septum. Atrioventricular node, AVN, is close to the atrioventricular septum. So it's between the atria and the other ventra. So this is the atrioventricular septum. So it's very close to the atrioventricular septum, the wall that is between the atria and the ventricles. It is a very it has openings also, but yeah, anyway, proceeding. Next we have the AV bundle. AV bundle is atrioventricular bundle. It passes through the atrioventricular septa and then it emerges on top of the interventricular septa. So it goes somewhat like this, and then like this, like this, and like this, right? And then it also emerges over here and here. So this is your basically atrioventricular bundle. Okay, now what is the function of this AV bundle? So this is pace setter, but what is this? This is meaning AVN is pace setter. Now your atrioventricular bundle is actually just, it has a right bundle, it has a left bundle. There's not much of function, it's just like spreading through the ventricles. It helps to spread the signal. And then Purkinje fibers are the main, like this is just like, to spread the signal, but it's mainly your Purkinje fibers which are like this everywhere throughout the ventricle. Your Purkinje fibers are present. They help in spreading the message throughout the ventricles, like this, like this. So it spreads throughout the ventricle. So this is your simple depiction of human heart, which is four chambered, and we also have like proper separation. We have complete double circulation. So this is your four chambered heart speciality. Now I want to tell you about the cardiac cycle here. So cardiac cycle is basically a sequential event that takes place in the heart cyclically and is repeated with each consecutive heartbeats. So first thing that happens in cardiac cycle is known as joint diastole. Joint diastole is the whole heart relaxing. The entire heart is relaxing and it is known as joint diastole. So in joint diastole, the entire heart is relaxed and all of our blood is basically flowing, right? The semilunar valves are closed. These valves are closed at this stage. The semilunar valves are completely closed, and all our blood is flowing through the bicuspid and through the tricuspid valves and filling into the ventricles. So these valves actually, tricuspid, bicuspid, they are open, and our blood is filling into the ventricle. It's mainly in the atria right now because it has come, here oxygenated blood has come in the left atria, and the right atria deoxygenated blood has come. So it's just sort of fully in the atria, and it's like slowly filling in the ventricle also. Now what happens during joint diastole is that the whole heart is relaxed. There is no contraction anywhere. Naturally, as blood is coming here, it is also naturally, due to gravity, it is going down. Natural thing is happening. Nothing, no active process, nothing is happening here. Now bicuspid valve, which is bicuspid and which is tricuspid, this valve here, this is tricuspid and this valve is bicuspid. I've also shown by the depiction. That's why I'll just rub it off because I don't have or maybe I'll just do it here. Yeah. So why this is a tricuspid valve is because backflow of deoxygenated blood back into the body is more dangerous compared to backflow of oxygenated blood into the lungs, because ultimately this oxygenated blood has to go back to the lungs for lung tissue to get oxygen. So flow of oxygenated blood into the lungs is harmless, but flow of deoxygenated blood back to the body is harmful for the tissues. That's why it can cause necrosis, death of tissue. So that's why this right here is a tricuspid valve, because backflow is extremely dangerous in case of right atria. Now let's proceed. Okay, now what happens is, next thing that happens is atrial systole. So our atria contract, so both atria contract simultaneously, and this sinoatrial node, it generates an action potential because of which both atria contract simultaneously, right? It causes both the atria to contract. This actions potential and sends to both atria, which stimulates contraction. Bicuspid and tricuspid valves are open. These valves are now remaining open. Okay, they are open. So blood flow increases by 30%. Now since they have contracted, so blood flow has increased by 30%. More and more blood is flowing into the ventricle, and it is emptying the atria. More and more blood is flowing into the ventricle, and the atria are becoming empty, right? Because blood is flowing into the ventricle. Right, so atria is becoming empty and ventricles are becoming filled. This is by 30% the flow has increased. This is known as atrial systole. The atria has contracted. Next we have ventricular systole, where both the ventricles contract and both the atria relax. So in this case, these valves close now, because now we don't want blood to go back to the atria, because most of it has come to the ventricles, and now we want blood to move to from here we wanted to go through the pulmonary artery to the lungs, and from here we wanted to go to the aorta. So now we want this is my pulmonary artery, I have drawn it down, and this is my aorta. Okay, because I didn't have place here, that's why I drew it down. Now these are the semilunar valves. Why are they semilunar valves? Because they are moon shaped, right? Simple. Now both the ventricles contract and the atria relax, and the action potential is conducted to the ventricles by what? AV nodes and AV bundle. So AV node conducts it to the ventricle, AV bundle also conducts it to the entire ventricle. So now the action potential is conducted throughout ventricle using these nodes and bundles. The bicuspid and tricuspid valves are closed to prevent backflow, and now your semilunar valves open forcefully. So when these close, now the pressure in ventricle increases. Now slowly it increases so much that these valves are shut open, right? Suddenly they open up. So when these valves open up, blood through these aorta and pulmonary veins, it flows into these pulmonary veins and aorta, and it goes. Okay, clear? So this happens. Now in ventricular diastole, what happens? The ventricles relax. Now after the blood has gone from the ventricle, right? Now blood is flowing from the ventricle, it's gone. The blood goes from the ventricle, right? It goes into the semilunar valves, sort of, right? So what happens is, now ventricles relax. Now when ventricular pressure goes down, the semilunar valves are closed again, because it is only opened by ventricular pressure increase. So when that pressure slows down, these valves are again closed. Now when they're closed, the ventricular pressure further decreases, and the bicuspid and tricuspid valves open, right? These valves open. So when the bicuspid and tricuspid valves open because of the increase of ventricular pressure, once again normally blood flows into the atria, blood flows into the ventricle. So this is your cardiac cycle. It's a little messy, but it has 4 stages. First is your joint diastole, where everybody is relaxing and blood is normally flowing into the ventricle through the atria. The bicuspid, tricuspid valves are open, semilunar valves are closed. Next is your atrial systole, where your atria is contracting so that blood flow into the ventricle increases. Bicuspid, tricuspid valves are open and your semilunar valves are closed. Third is ventricular systole or atrial diastole. So in your ventricular systole, what happens is, your bicuspid and tricuspid valves close, and all of the blood starts filling in the ventricle, and the ventricle pressure starts increasing, which forces the semilunar valves to open. So closure of, whenever something is closed, whenever we close a door, right, whenever we shut a door by pressure, there is a loud sound. So that loud sound due to the closure of bicuspid and tricuspid valves is known as lub. It is our first heartbeat. So our first heart sound is because of bicuspid and tricuspid valve, it's known as lub. And the last thing in the cardiac cycle is ventricular diastole. Yeah, ventricular diastole is very important. because ventricular diastole is when your valves are closed, right? Semilunar valves are closed and the bicuspid tricuspid valves open, so this is known as ventricular diastole, when ventricles are relaxing now especially, right? So in this case what happens, semilunar valves are closed. So because of the closure of semilunar valves, the second heart sound dub is produced, because the semilunar valves are closed. So we have the second heart sound dub. So lub dub happens because the dub is due to closure of semilunar valves, lub is due to closure of bicuspid and tricuspid valves. Now there are about, in 1 minute our heart beats 72 times, because pacemaker has about 70 to 75 action potential per minute, so average is 72 beats per minute, right? So when it beats 72 times, one cardiac cycle's duration, you can guess, 72 cardiac cycles happens in 1 minute. So 72 by 60 is equal to 0.8 second. One cardiac cycle lasts for 0.8 second. So in 0.8 seconds our one cardiac cycle is over. Now in case you want to know how much volume of blood each ventricle is pumping in 1 minute, it is known as cardiac output. This cardiac output is equal to stroke volume into heart rate. Now what is stroke volume, you may ask? How much blood a ventricle is pumping in one pump, okay, है ना, एक पंप में एक वेंट्रिकल कितना ब्लड पंप कर रहा है, एंड दिस इज द नंबर ऑफ बीट्स पर मिनट. तो एक बीट में वेंट्रिकल कितना ब्लड पंप कर रहा है, स्ट्रोक वॉल्यूम. एक बीट में कितना ब्लड पंप कर रहा है, स्ट्रोक वॉल्यूम. और कितनी बार पंप कर रहा है, हार्ट रेट. ये 72 है, ये स्ट्रोक वॉल्यूम है, ठीक है, एंड दैट इज इक्वल टू कार्डियक आउटपुट. नाउ इन केस ऑफ एन एथलीट, उनकी हार्ट रेट इंक्रीज हो जाती है, their stroke volume increases, so their cardiac output is much greater than an ordinary man. So this is just some information that I'm giving to you that you can know, and just in case you want to know the average values of cardiac output is equal to stroke volume. Let me write the full forms. Cardiac output is equal to stroke volume into heart rate. Now if you want to know the average values, this is about 70 ml, right? This is about 70 ml in one beat. Each ventricle pumps about 70 ml of blood, and this is about 72 beats per minute. So this comes off approximately as 5000 ml per minute, or 5 liters of blood. So this is all for today. Thank you for watching. Make sure to subscribe.